Hello everyone, and welcome to Jenesis Designs and Motorcraft, but not the bench, not today. Today I'm at a secret location with famous Chris Jones.
Shush.
Chris Jones is no shush.
Made me blush.
He's a very well-known contributor to Airfix Model World magazine, a friend of mine, and we've come down here today to check out the weather.
It's very British, isn't it?
It's very British. We're in a very British, random business industrial estate on the south coast of the UK to visit Airfix. We're going to see the facility where the new 124 Spitfires created, moulded, etc. and learn lots about it.
It's going to be exciting, huh?
Let's do it.
Yeah.
The venue for the visit on this beautiful November morning was Plastech Tooling and Moulding Limited, situated in Newhaven, which is between Brighton and Eastbourne in the UK. Because my name was indeed on the guest list, I had no problem passing security, and upon entry to the factory area, I was greeted with this motley assortment, crack team of the UK's top magazine editors, journalists, YouTubers, content creators, and general bigwigs of the modelling community. Being a working factory situation, the background noise of people working was ongoing throughout all of the presentations that were given, and there were also obstructions to me videoing properly. So because of that, I've decided to actually present the slideshow myself in a way. But just to give you a taste of proceedings, here's Dale Luckhurst talking about the reasons why your Spitfire kit may not have gotten to you as quickly as you would have liked.
This is essentially their goods out space. So we can't fit 5,000 Spitfires in this space here, ship them to Canterbury, Margate, and then out to retailers. So what we had to do is phase the batch of those out to market. Obviously the product is already available on airfix.com for 5 days before it was then sent out to trade. It wasn't purposely kept back for 5 days before hitting the trade, but 5 days after, we then got the next batch from the guys here, and that went out on Thursday to the first batch of trade accounts. This week, this Thursday, we should get a larger batch, and then it goes out to the next group of trade accounts. Okay, so that we're just having to manage that. It's a pain. I would much rather just hit the UK with a big lump in one hit, but it's just something that we've had to manage because we're going to make it in the UK, or we are making it in the UK rather. And what a fantastic thing, an opportunity it is to make this a beautiful kit in the UK. We ummed and ahed about it, obviously. The commercials and bits and pieces is something that we're always looking at, India versus the UK, but we just felt that this kit, being the super kit and being an icon that it is, had to be made in the UK.
The presentation was given by researcher Luke Slaney-Hewitt, who had a big hand in the project, helping out the kit's actual designer, Chris Parker-Joy. Chris will no doubt be ecstatic to realise that his favourite ever design project is again on sale in Aldi's aisle of assorted items you never knew you needed, just in time for Christmas. So the presentation began with Luke, the researcher, taking us through some of the reasons that Airfix actually picked their subjects, which is possibly interesting to most because it does sometimes seem a little random. Here on the slide you can see the factors that they take into account, the release schedule, the growth of their ranges, gaps in the market is a fairly obvious one, previous sales and or aircraft notoriety, so you know the Spitfire sitting in the middle of the picture for good reason there, and then rule breakers because the Swift just doesn't fit into any of the rules which were previously stated, like how many versions of a particular type or subject they can get out of the one mould, because it really is just one version with the Swift, and the Walrus is much the same on that one actually. And once the subject is chosen, here are some of the stages that the team go through on the way to producing a design and the kit itself. Locating source material is a huge part of the deal, and from lots of different places. It's no good necessarily to just trust one internet expert on something. You need to have lots of different sources, collate all your different evidence together and try and make sure that what you're doing is correct. And that can be very difficult, obviously, with older aircraft, but even perhaps less obviously with more modern aircraft because of copyright issues and data access and secrecy acts and so on and so forth. The design team do work as a team. The designer does design the kit single-handedly in Airfix's case, but he doesn't work alone. Despite that, the team do help each other out, and the researchers help the designers to back up what they're doing, to check what they're doing, and to try and keep everything going in the right direction. It's always the same, isn't it? Every time a new kit gets released, all the modelers cry, "Whoa, why another Spitfire? Don't we have enough Spitfires already? Why is it this scale? I wanted it in that scale," etc. You know where I'm going with that. So the Spitfire is an obvious choice, of course it is. And Airfix do have a very solid history with the type. Their very first kit, released in 1955, was of the Spitfire and was considerably less accurate than the latest one, let's just say. And it has through the years been their most popular subject. I believe it was the first super kit that was released, was the original Spitfire 1A, with the best ever box art, in my humble opinion. It's my favourite box art out of all of the box arts of Kiwi there. Why do another Spitfire in 1/24th scale? Well, because no one else has. The Spitfire Mark 9 hasn't been done in 24th scale before at all. So it is, despite being a Spitfire, actually definitely a gap in the market. The research process itself then is multi-pronged, and lots of different sources of evidence are collated. And one of the big ones is actually actual manufacturer's drawings, although these can be very difficult to translate and in a lot of cases aren't available at all. There is a lot of information out there on the Spitfire, thankfully, and a few examples are reproduced here on the slide of manufacturing drawings, which usually have good dimensional information and such like on them. But you have to remember that these aircraft were hand built, and although the tolerances weren't immense, we're not talking about probably even inches, there were tolerances due to them being hand built in different locations at a time of great industrial duress. I suppose one of the best things about doing a Spitfire is the relative ease of access to original aircraft that still exist, in comparison with something like, say, a short Stirling, where there are virtually no parts or aircraft to be had or looked at. There are a lot of Spitfires around these days, but the problem is, obviously, a lot of them, if not all of them, have been rebuilt to some extent or another, so they can't necessarily be relied upon as accurate examples of how they actually were when built. And for that reason, the researchers do look out for original parts of aircraft that haven't been restored, as shown here, and actually things like pilots' manuals and such from the period, because they have a lot of diagrams and photos which are reasonably clear and help to show features. But I do think it's important to realise that even though modern warbirds or rebuilt aircraft can differ from original, the major airframe structural detail should be broadly pretty much the same. And here's an example of the pilot's notes for the Spitfire, showing some photographs of the cockpit area. And these photographs are quite odd when you look at them, because they're sort of hyper contrasty, almost, I think, potentially retouched, but because they are, it is quite easy to see all the details, as you can see here. And on top of that, all of the information is present also, so you're not trying to guess what that particular control wheel button or toggle switch is for, because it is in fact noted, being the pilot's notes. So to begin the actual design process then, how do they do it? I'm sure I don't know, but Chris did go some way to explaining how it's done. And he spent some time explaining how excited he was about the image you can see now, which is a lot of numbers, so to most people potentially incredibly uninteresting. So this is a data table of fuselage frame ordinates, so it's dimensions basically, which use a kind of a grid system to build up points in space where the fuselage frames are. So all aircraft have data points and a way of measuring them which produces these points in space. You have a datum line which runs forward to after every aircraft, and a datum point 0, which is usually somewhere around the nose, and each frame is measured back from that. You then have butt lines and water lines, no giggling at the back, which describe the width and the height of each of those dimensions, and that's what that table represents. The table was created by Paul Monforton when he wrote his book, Engineering the Spitfire, and it used a combination of factory data, and in fact he measured himself 5 separate Spitfire 9 and 16 aircraft, so it is reasonable to assume it's at least quite accurate. So the first thing Chris did with that set of data points was convert the numbers into metric, and those metric numbers were then used to plot out a half section of the fuselage. It's quite simple looking at this stage, but you can already see how those points in space have built together to create a set of frames, which already you can see the shape of the aircraft emerge. The next stage in that process is to add a skin, much like you would to build a real aircraft. You put a load of frames up and then you add some skinning. So the skinning has been added here, and the sections that you can see protruding are to do with joint lines and mould tooling lines and things like that. Here you can see how he's looking at the other side, at the inside of that half shell, and is starting to plot out things like where the parts split for the kit and where different aspects of the interior sit and how they all interact with each other and the other parts of the kit. With all of that laid down, the surface detail comes next, and here we've got detailed drawings which help us, and again these drawings are from the Monforton book, showing every last rivet in the skin structure, every single one, the size of them, the pitch of them, the spacing of them, it's all there. So the part progression is shown like so. You have that basic skinning with the initial part split shown with that section there. Then the parts are removed or cut out, so that you have there, looking at the engine side panel, you have the removed part by itself. And then panel lines are added to that part and the details. So the first and the second row of pictures, you see that the exhaust cutout has been added in and a panel line added. And from there, he's gone on and added the quarter turn fasteners, which hold the cowling on. And finally, the actual rivets themselves. The third row of images shows then that completed riveted panel, to which the last thing he's added is the access hatches and the mounting for that little air scoop on the left hand side there. And then you can see it in situ on the CAD model as a finished part. And throughout all of the operations that are ongoing with designing the parts breakdown, the surface detail, the shapes and everything else, Chris is also having to think about the parts breakdown and how he can ensure that we have the amount of surface detail and moulding precision that we like to have as modellers, and we are an exacting bunch, very difficult to please. So he realised fairly quickly that the shape of the radiator housings does not allow for surface detail to be adequately moulded on the sides because of the injection moulding process. So the decision is made to split the scoop into 3 sections, as you can see there. But then the concern was that the 3 sections could be a little difficult to align, a bit wobbly, a bit flimsy and a bit awkward, until he realised that that scoop is there to house a radiator / oil cooler, and that in fact if he were to add some notches to the internal part for the radiator and some locations on the radiator scoop, all of a sudden he's got a nice sturdy backbone to build that scoop onto to enable it to be foolproof. I use that word advisedly. Easy to construct and somewhat sturdy once constructed, rather than a potentially fiddly and flimsy assembly. Now, as well as surface details on this kit, there are also textures, which I find a very welcome addition, because if there's anything that helps to lift a model from something which looks like a model to something which looks like a replica, it's things like texture, because they do vary quite dramatically on real aircraft for the most part. So you're showing here different materials because we've got metal, fabric, we've got radiator grills, and showing there the seat back where he has tried to impart some form of shape to that leather seat backing pad, which he says was very difficult because his design program is really very suited to producing structured items and not so much to producing organic looking items. Great attention was paid throughout to trying to represent all the sorts of fastenings that are on the aircraft, panels and fittings, to try and make them as accurate as possible within reason. The stress skin effects, or panting, were produced by looking at photographs, images, videos, etc. of the real thing. The kit, this aircraft wasn't scanned. This kit was not designed from a LiDAR scan. I know Airfix are quite well known for laser scanning their subjects to enable them to be as accurate as possible. But this kit was designed during the COVID lockdown here in the UK, and because of that, the real aircraft wasn't scanned and wasn't visited anywhere near as much as the team would normally like to do. So that surface detail that's been added has been done manually by Chris using standard references. At this point, I feel it's probably worth mentioning the pilot issue. Many will have noted already, and I've certainly seen comment in various places, that the kit does not include a pilot figure, which some see as a bad thing, and this was mentioned during the presentation. And as I've just alluded to, Chris did say that his software isn't very good at producing organic shapes and things, so to make a figure, it is for him very, very difficult, if not bordering on impossible. So in order to provide a pilot, the design work has to be contracted out somewhere else, somewhere that specialises in doing figures and have software to suit. And because of that, it's actually inordinately expensive for Airfix to do that in this case. So before everybody starts saying, yeah, but all the 70-second kits have got pilots in, or similar, those pilots are already designed and to a degree can be inserted into any kit as they are. Not the case with this one. Because of the size and complexity and detail involved, the pilot does need to be at least a little bit convincing, I think. It needs to fit properly and needs to look as though he's meant to be there, and because of that, needs to be designed for this kit specifically. This would have added a lot of money to the process, and it was felt that it would add enough to make the kit go over the £100 mark that Airfix set themselves when they started the project. And that is why there's no pilot figure in the kit. Once the designs are essentially complete, and I think that took around a year in this case through the lockdown period, the first step in testing that design is to get the parts 3D printed according to the CAD drawings that have been made. And this is something that Airfix have had to send out for up until now, but they do now have their own 3D printers to do this in-house. And when the big box of parts arrived at Chris's house, this is what it looks like. A big stack of plastic bags of individual parts. No handy runners and sprues for this designer, just a big box of single parts, which he then had to organise. And utilising his own inner OCD, this was the result of that organisation. Laying the parts out across a wide area, much to the delight of his wife, apparently. And these parts, over the course of about the next month, were in fact built into the first ever built example of this kit. And during that build process, what he's looking for is to ensure that all of the parts fit together as wished. It all sort of works and comes together as a whole the way it's designed to do, which obviously it should, but there's always issues when you actually start to build things, best laid plans, etc. So here it is. As he's gone along with this, he's recorded the issues that he came up against and looked, if there's any problems, looked for ways around them, looked for ways to solve them, looked for any parts that don't fit as well as would be liked. One example of that is here on frame 5, or the firewall, or the bulkhead, whatever you would like to call it. So note in the photograph where it's being held, you can see the slots at the 11 o'clock and 1 o'clock positions don't quite line up between the firewall part and the actual fuselage skin, or the fuselage half. And on the right there you can see that area highlighted on the drawings, and that was massaged in the CAD to try and correct that very, very, admittedly, very minor fit issue. And you remember I said earlier that Airfix did not LiDAR scan the Spitfire, and yet here I'm showing you a picture of exactly that. As the country came out of lockdown and the Airfix team were more able to go around and do the things they needed to do, one of the things Luke went and did was he went to Biggin Hill and he scanned this TR9 Spitfire two-seater. And when that data was looked at and overlaid on the CAD designs that had been done for this Mark IX kit, everybody was very, very happy to find that it matched up extremely closely, thus validating actually all the design work that had gone into the project so far and the sources used for it. And once the actual design was finalised, obviously the next step is tooling it up, and of course all of those design parts needed to be fitted into frameworks to make tools. Right from the off, this project, one of the headline features of the project at Airfix was that this kit needed to be under £100. And they wanted a sensible sized box, both things of which I greatly approve as it happens. And the box is a very sensible size. It's really not much bigger in footprint than the Tamiya 32nd scale kit, but it is deeper. Anyway, here's a reproduction of one of the tooling layout diagrams, and you can see all the parts labelled down the side there. And to put a subject to bed that came up in my review video, no, the tools were not produced in the UK. I thought maybe that they were, but it turns out that the tooling was actually cut in China, and it was done with the spark erosion process, much as most other kits are. I did ask Dale Luckhurst how far away we were from potentially producing tools in the UK, and he said quite far. It isn't an issue of capability. There's absolutely no problem with producing tools like this in the UK. Plastech can actually do it there in-house. The problem is cost. It's very, very, very expensive to have it done here in the UK, and that is why the tooling itself has still been produced in China. The factory over there would send back progress pictures and obviously keep in touch with Airfix throughout. And here's a photograph of the tooling during that production phase. As I said, spark erosion, or as it says there, electrical discharge machining. I actually saw this process in action when I was lucky enough to visit the Trumpeter factory quite a few years ago now. It's quite fascinating to watch, and takes a long time to do. It's all done in a sort of an oil bath, and all you can see is this little spark going away down there in the fluid, and it gradually just eats away at the tool material to produce this replica of itself. It's very clever. And the net result of that process eventually is test shots. We've all heard of test shots, and these test shots are sent back to the UK. Presumably some are built over there, I don't know, but they come back to the UK and they get built up at Airfix HQ to make sure everything works. Now obviously this was already done with the 3D printed parts, but this is from the tooling, so it could be a very slightly different animal. And those parts were put together, everything checked to make sure the quality was where it needed to be and to make sure that all the parts were going to work. And it was during this process that small changes can be made if problems are found. Obviously, big changes are going to cause issues, and as Chris said, it's very much easier to remove material than it is to weld the tools and then remachine them. And one of the things they picked up on was just widening the tailplane attachment slots a touch to allow for a slightly less tricky fit. And as you can see there, they're sending an annotated drawing back for the feedback process to say please remove 0.25mm of material from the highlighted area, just to make that fit a little easier. After the presentations were complete, we were then given the opportunity to take a tour around the factory with Plastech managers Mark and Matt, and they showed us some of the things they do there, some of the tooling in action. Again, there's a lot of background noise, but here's a little snippet of one of the tools producing an actual sprue for this kit.
Right, hopefully you'll be able to hear me over the machines. The first thing I'm going to do is take you over to what we call our machine 7 here, and we'll have a look at one of the tools running. Okay, so let's go. Stick with me, follow my line, you'll be perfectly safe. you got? Because you've got cameras.
Stick with me, he says. Everything will be fine, he says.
Yeah, he'll be fine. So this is one of the frames running now, which is frame D, E, N and J. And you guys are all welcome to come in if you want to take it one at a time to have a look at the... I don't know if you've ever seen a moulding machine operating. It's quite interesting. So the plastic comes in there, comes down, gets pushed in under high pressure, goes into the machine, which is obviously heating the plastic up to the right temperature, and then it will sit in there now under pressure until it's cooled enough that it will allow to open. Okay. And we actually have it running quite fast compared to most machines. So what we have to do here is have two operators, and what they're doing is they're actually quality controlling the parts that are coming off. So we have what's called a shadow board, which I'll show you in more detail on the other side. So you can check to see if parts are missing, but it's not just if parts are missing. There's areas where you can have sink, you know, especially on these parts here, you know, you could have a massive bit of sink, and you know, you wouldn't want to fill that in if you're a modeller. It's just got to be right. So that's what we're doing. Sometimes you'll have a little bit of flash, which can occur around the edges, but that's not a problem because you can always turn that off. We don't like that. Some of these parts are actually moulded flash. Now flash is obviously the bit where faces don't quite seal up, you know. But some of these parts, like this part here, which is number 6, you can see those bits inside there, they're actually just flash. You know, we're talking microns, we're not talking millimetres, this is 1,000th of a millimetre, you know. So to actually get out to mould, if you take some of the material away, even a little bit, you just have holes. You know, it's fascinating. You're moulding flash as well as flash appearing on the frame, so you have to try and control that, but also still fill it. So it's a little challenge, but one we like. So have a look at that. I'll come out your way, guys, and you can have a proper look at the machine running. Probably for every 10,000 products, probably only one way to see.
I have to apologise about the slightly abrupt, well, very abrupt cut between those two clips there. But with all the background noise and my limited skill at video editing, that's really the best I can do. The packing station there was quite interesting. The piece of carpet is not there to soak up excess parts from the sprues. It's actually there to protect the white bottom box part of the kit when it's put together. That lovely white box that Airfix provide. The kind people at Plastech did not want to scuff it and mark it up before it even got to you, the customer. So that's all that is for. And they did confirm that the paper is there in an attempt to reduce single-use packaging, which is also a good thing in my opinion anyway. I personally found the sight of quite so many Spitfire kits all stacked up together like that quite exciting. Anyway, enough said from me. It was a really interesting day. I want to thank the team at Airfix for the invite. I felt very privileged to receive it and to go. And I'd also like to thank famous Chris Jones for accompanying me. I think he had a good day too. So I'll cut to the outro, filmed on a typical November day on a wet and windy beach on the south coast of beautiful England. And with that said, it only remains for me to say thanks for watching. Look after yourselves, look after each other, and Genesis out.
See behind us?
But then the wind will blow the hair away.
Oh, we're recording!
Yes!
Reassuringly high projection values.
Yeah!
So, the Airfix Spitfire Press Day. What did you think, Jen?
It's cold.
It's really cold.
We learned all about it.
Yeah.
Hopefully,
It was good.
you've seen it all in the video. We even got, oh gosh.
we want. The weather is fine, it's fine.